Anyway, last week was test week. So a lot of you people got everything turned in, did the discussion-based assessment, turned the test. Some of you have turned the test in and haven't done the discussion-based assessment. So at the end of class today, if we have any time at the end of class, I will let people do the discussion-based assessment that wants to. So at the end of class, just put in the chat, DBA, discussion-based assessment, or I'm here, or whatever at the end of class, and I'll just take them in the order that they're in the chat, and we'll do it until I run out of time because I only have so much time to do this. But that's only people. See, most people did it last week when you're supposed to sign up for it. If you didn't do it last week, you need to get it done this week because that's part of your grade for the last week's test. All right, we're going to get going here. Let me put this up on the screen. Going to kind of go in a different direction today, study something maybe you haven't spent a lot of time studying. Maybe it's stuff you've never studied. I'm not sure, but let's see. Let's look at our grade screen as usual to start out. If we look at that, all of Unit 1 should be turned in. Should not be anything left for Unit 1. Module 1 is finished. We are now ready to start Module 2, Rational Exponents, Complex Numbers, Polynomial Operations. So we got lots today. See, we're taking 2 units a week. So this is going to last 5 weeks. 5 weeks. Now remember, you can still turn in Unit 1 late work until we finish with Unit 2. That means if you're missing anything from the last unit, you got 5 weeks to get it turned in, and then it'll be a permanent 0 if it's not turned in. So you got 5 weeks to get caught up on anything you're missing back here. But that means you also need to keep caught up with this because you don't want to have zeros down here as well. So, but yeah, we are starting Module 2. So make sure you got everything turned in from Module 1. And I'll go down here. I'm going to close this folder since we're done with that. Open up Module 2 folder. All right, looking at the first 2 lessons, we're going to talk about rational exponents and then properties of rational exponents. Because next week we're going to be solving radicals, and radicals and rational exponents are very much related to each other. So page 1. All right. We'll start with a little English. Got some word pairs here. Big, large. Easy, simple. Thin, skinny. Fast, quick. Tired, sleepy. Synonyms, right? Words that mean very much the same thing. They're all synonyms, 2 words that have the same meaning. There's similar concept in mathematics. When 2 different mathematics statements have the same meaning, those are called equivalent expressions. Equivalent expressions. And we've seen tons of those. Like 8 plus 3 and 5 plus 6. Those are equivalent expressions because both of those equal 11. It's just 2 different ways of saying 11. 12 minus 5 or 10 minus 3. Equivalent expressions. 5 times 2, 1 times 10. 25 divided by 5 or 45 divided by 9. Those are equivalent expressions because you're saying the same thing. Either of those are 5. Or even in fractions, 8/10 and 4/5, right? Because those are equivalent. Those equal the same amount. So after completing this lesson, we're going to be able to answer the following question. How can an expression written in either radical form or rational exponent form be rewritten to the other form? All right, so let's start page 2. Rational exponents and radical expressions. Will the same process apply when numerators are greater than 1? Let's take a look at the rational exponent t raised to the power of 3/4. Told you this is something you probably not spent a lot of time studying. So t to the power of 3/4 is the same as t to the 1/4 times t to the 1/4 times t to the 1/4. And if they were rewritten as radicals, here, let's do this on paper because we need to take some notes on this. If we don't take some notes on this, then we're going to be hurting when we start actually working these problems. So it'd be good to have some notes on this. It said t to the 3/4. That's the same thing as t to the 1/4 times t to the 1/4 times t to the 1/4. So that's great for our notes. Now remember that because we multiply things that have exponents, you can add the exponents together. 1/4 plus 1/4 plus 1/4 is 3/4. See, so that's the same as t to the 1/4 plus 1/4 plus 1/4. That's equivalent expressions. All those are the same thing. But we can write this as a radical because t to the 1/4 is the same thing as the 4th root of t times the 4th root of t times the 4th root of t. This is the same thing as that. That's with a rational exponent. This is as a radical. Rational exponent. Radical. So this written as a radical is the 4th root of t to the 3rd power. The 4th root of t to the 3rd power is the same thing as the 4th root of t times the 4th root of t times the 4th root of t, because you can multiply those together. T times t times t, and just do the 4th root of t to the 3rd power. So that's great for your notes to know the difference between a rational exponent and a radical, and these are all the same. There you go. I wrote same on the side. These all have the same value. This is the same as that. It's just written in radical form instead of rational exponent form. So that is great for your notes right there. All right, we're going to watch this little video.
The expression f to the 3/7 power has a rational exponent. It is the same as f to the 1/7 power times f to the 1/7 power times f to the 1/7 power. These factors can be written as the 7th root of f times the 7th root of f times the 7th root of f. When radicals of the same root are multiplied, the terms inside the radical are multiplied. But it is important to remember that the numerator of the fraction becomes the exponent on radical. So f to the 3/7 power is equivalent to the 7th root of f cubed.
Okie dokie. So that was talking about how you convert from one method to the other. So that would be great to put in our notes. So let's just use something we're more common seeing. Let's say x. All right, so using x to the 3/5 power, that would be the same thing as the 5th power of x to the 3rd. So notice what happens. Whatever's on the bottom becomes the outside part of the root. So it's the 5th root. 5 goes right there. Whatever is on top goes underneath with the radicand right there. So the 3 would go right up there. So this is basically, if you're looking at it, it's x to the 3rd power. And then what's underneath there, we're taking the 5th root of that. We're taking the 5th root of x to whatever's on top. See, this was t to the 3rd power, so the t to the 3rd goes underneath here. But it's being taken to the 4th root, where this is being taken to the 5th root. So understand how to convert that. I know someone out there, probably more than one of you, is going to make that hard. If this is in your notes, that should be pretty simple, right? We should be easily being able to rewrite from one to the other. The 3 on top goes inside with whatever the variable is. The number on the bottom stays outside. So making sure your notes show you how to do that. And you could go the other way just as easily, right? Whatever's inside there as an exponent goes on top of the fraction. Whatever's outside goes on the bottom. So you shouldn't have any trouble. If you've got that in your notes, should be very simple to go back and forth. Don't make a careless mistake. Do that wrong. Rewrite 6x to the 4/5. Okay, this gets a little tricky because the 6x, let's talk about that real quick. 6x to the 4/5. That is different than this. Different. This one would be 6 times the 5th root of x to the 4th. This would be the 5th root of 6x to the 4th. See the difference? The parentheses say all of this is being raised to the 4/5 power. This says 6 times x to the 4/5 power. So just x to the 4/5 power times 6. This is 6x to the 4/5 power. So the 6 would just stay out front and be multiplied by the 5th power of x to the 4th. I mean, the 5th root of x to the 4th. Where this one, all of it goes underneath there because it's in parentheses. So that's important to make sure you know when to include the 6 under the radical and when not to. So it's not part of the radicand on that one. So it says drag the numerator and denominator to the correct location. 4 is the numerator. So let's see, here are the numerator and denominator. So since that is the numerator, we're going to put it in there with the square root. This one's going to go outside. So it'll make 6 5th roots of x to the 4th. All right, let's go next page. Lots of videos this lesson, by the way. Radical expressions to rational exponents. And there's the same thing that we just looked at. The 5th root of x to the 3rd is x to the 3/5. So this goes through, and again, if you don't have it in your notes by now, you need it there. It can go either direction. This is going the other way, starting with the 5th root and ending with the rational exponent. But you can go either way. All right, let's look at another video.
The 8th root of w to the 5th power is written in radical form. It can be written as the 8th root of w times 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 the 8th root of w. Now, each radical can be written as a rational exponent. So, the 8th root of w to the 5th power equals w to the 1/8 power times 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 w to the 1/8 power. What happens when the rational exponents are added? You'll see that the exponent on the original radicand becomes the numerator of the exponent, and the index or root of the original radical becomes the denominator of the rational exponent. So the 8th root of w to the 5th power is equivalent to w to the 5/8.
All right, so it's all about knowing which number goes on top of the fraction, which number is on bottom of the fraction, right? As long as you got that in your notes, that should be very easy to go back and forth. Very easy to go back and forth. Just knowing which number goes on top of the fraction, where's the number on bottom. All right, here is the 7th root of 10x. All right, so the 7th root of 10x, so that would equal 10x something. There's a 1 as the exponent, right? So in the fraction, there's just going to be a 1 on top. 10x to the 1, and then the 7 is on the outside. So it's 10x to the 1/7. Now notice, since the 10x is underneath the radical, we have to put in parentheses out there to say all of this is taken to the 1/7 power, because all of that is underneath. So we need parentheses around it to show that everything in there is to the 1/7 power. Okay. Lesson summary. See, that didn't take long. It's only 2 pages because we're just talking about how to go back and forth. That's all this lesson is. How can we go back and forth from one to the other? So if you have a rational exponent and you need to make it a radical, you take the 3 from the top and put it underneath the radical. You take the 4 on the denominator and it becomes outside to show that it's 4th root. It's the index of the radical. And then go in the other direction. If you have the 8th root of w to the 5th power, whatever the exponent is inside the radical stays on top. And the number on the outside, that index number, is your denominator. So that is that whole lesson, lesson 1. So that is a nice little warm up because we need that for the rest of this unit. If we can't do this, we're going to be lost the rest of the unit. Absolutely lost. So make sure you understand this lesson. Here's the assignment that goes with that. Which of the following is the radical expression of a to the 5/7? All right, this is one of those lessons, guys, that if you have not changed your theme in Buzz, I can't do it from here. I got to get out of the lesson. If you have not changed your theme in Buzz, you are not going to be able to see these problems. Oh, I still got to get out of that. When you click on your name up here, it's got choose theme, and that's where make sure you're on light color scheme. If you're on dark color scheme, here I'm going to put it on dark color scheme and go back to this lesson just to see what it looks like, what this assignment looks like. Oh, look at that. It's hard to read any of the multiple choice ones over here. The top 2 are really bad there. You know, that's very, very difficult to read. Some of these choices, I don't even know what they are. Don't know what it's asking me there. Gets to be a real mess. So make sure before you email Mr. Brock, say, Mr. Brock, I can't see the numbers. Change your theme. Go to the light color scheme. You can choose whatever color you want for accent. Like I've got the red one, so the menu bar is in red. But make sure you're on light color scheme. Then when you save that, now you'll be able to see the actual problems. See, now we can read these numbers. A to the 5/7, 2D to the 7/10. Couldn't see that with the dark. But anyway, there are 5 problems just converting back and forth between radicals and rational exponents. So let's look at our second lesson because that was the simple one. But without that one, we're stuck the rest of the unit. We got to be able to do that. All right. We're going to talk about the properties of rational exponents because if we're going to be able to solve them, we got to know the properties. And the properties are basically the rules. So we're going to learn this. How can the properties of rational exponents be applied to simplify expressions that either have radicals or rational exponents? So let's review operations with fractions and conquering fractions. Okay, so this is going back before algebra. I'm going to put this up. All right, get that up on the screen. Let's go back to just basic fractions in case you have forgotten the basic rules of fractions. If we are adding 2 fractions, 1/2 plus 1/4. In order to add fractions, we must have the same denominator. So we need 2 goes into 4, so we need to multiply this by 2/2. Because 2 times 2 would give us the 4. And what is 2/2? That's just 1, right? Anything divided by 2 divided by 2, that's just 1. So I'm just multiplying it by 1. That's all I'm doing is multiplying this number by 1, which means I have not changed it. I've only changed how it looks. So 2 times 1 is 2. 2 times 2 is 4. And now I can add the 1/4 to it. 2/4 plus 1/4 for adding. So let me write this. So adding would be 3/4. So to add have to be the same. And that makes sense because think about a pizza pie. If I have half a pizza, I've got half a pizza, and I have a fourth of a pizza, because this is a fourth, right? 1/4. That means I have just this much of a pizza. If I put those together, I have that. I'm going to do this half this time. So I have half a pizza plus a fourth of a pizza. That gives me 3/4 of a pizza. That's how a fraction works. If we have a half and a fourth and put them together, we got the half and the fourth. We have 3 out of 4. Cut that in half, cut that in half. That's 1, 2, 3, 4 slices all the same. 1, 2, 3, 4 all the same. And we have 3 out of 4. So adding. Let's talk about subtracting. But you need this. If you don't know this by heart, this should be in your notes, because we're going to use this a lot, because we're going to be working with rational exponents this whole unit, which means fractions. Subtracting works just like addition in the fact that we have to have the same denominator. So again, let's multiply this by 1. And this is how my 1 looks like, 2 divided by 2. 2 times 1 is 2. 2 times 2 is 4. And so you keep the denominator and subtract the top. 2 minus 1, 1/4. Well, that makes sense as well. If we have half a pizza and we take 1/4 of it out, we only have a 1/4 of it left. Like here we had a half. Here we took out this 1/4 right there. Now we've only got a 1/4 left, 1/4. So that's subtraction. Let's talk about multiply. Multiply is probably the easiest when it comes to fractions. Because multiply, let's say we've got 2/3 and we're multiplying it by 3/4. Multiplying, you just multiply 2 times 3. That's 2 times 3 and 3 times 4. So it's 6/12. We can simplify 6/12 if we divide it by 1, and here's the 1 I'm dividing it by. 6 will divide into both those numbers. So 6 divided by 6 is 1. 12 divided by 6 is 2. 6/12 is the same as 1/2. Remember, you can always multiply or divide by 1. And you can just choose your 1. 2/2, 6/6, 5/5, whatever your 1 needs to be. Because that does not change anything when multiplying by 1. We learned that way back in elementary school. Multiplying by 1 does not change anything. Dividing by 1 does not change anything. So here's the last one. Dividing. 2/3 divided by 3/4. Okay, to divide fractions, I'm going to highlight this one. To divide fractions, you take the number you're dividing by and turn it upside down and multiply. See our 3/4 turned over to be a 4/3. So we changed it from division to multiplication. So now this is 2 times 4, which is 8. And times 3 times 3, which is 9. 8/9. So to divide fractions, you take the reciprocal of this, turn it upside down, make it 4/3, and that's it. So that's our little review on add, subtract, multiply, and divide fractions. So there we go. It's kind of fun to go back before the days of algebra. Go back to some of our elementary school lessons. and have this nice summary on here. All right. Everyone's taking notes. Got that in your notes? Okay, and conquering fractions. Let's see what that one's reviewing. I know the fraction operations. I'm not sure what they're reviewing here. Oh, writing it in its simple form. That's simplifying. 6 over 16. Well, you can divide that by 2 over 2, right? So that becomes 3, and that becomes 8. So it's 3/8 because I'm dividing it by 2 over 2. So that's got some of that. Let's see what else. Simplifying, write in simplest form. So this is a whole bunch of practice on simplifying. Oh, here you go. Add these together and then simplify if you can. Well, when you add those together, it's already simplified. So there's just some practice problems for you in adding, subtracting, and simplifying, and multiplying, and a couple divides. So there's a little practice for all of those. So if you need some practice, if you're not sure, gosh, do I understand what I'm doing with fractions? There's a little elementary school lesson for you where you just get to play with fractions with no x's, no y's, no algebra whatsoever. This is before algebra, just using fractions back in elementary school, and a bunch of practice problems. 16 practice problems right there. So some of you may need that. If you don't like fractions or don't use fractions enough to get comfortable with them, then you need to go click on that. All right, example 1. You already know how to multiply and divide radicals of the same root. The radicands are multiplied together while the index remains the same. Like the third root of 2 times the third root of 3, you can multiply what's underneath because they're both third root. So 2 times 3 is 6. But what if we have different bases? The fourth root of n times the square root of n. That's a fourth root, that's a square n. We can't say it's the fourth root of n squared. We can't say it's the square root of n squared because it's different. So there's some other properties we need to review. Other properties we need to review. So let's get our notes back out and look up the properties of exponents. Since we're using exponents that are also fractions, it's good to review how fractions work. It's also good to review how exponents work. All right. So, let's see. What all should we review on exponents? All right. If we have x to the second, if we take x squared times x to the third, what is that? That is x times x, right? That's what x squared is, times x times x times x, because that's what x to the third is. So we just have x times x times x times x times x, x to the fifth. So that means it's the same as x2 plus 3. We can just add the exponents. Multiplying. So I guess I should write multiply over here. When multiplying exponents, we can just add them together. The one it was wanting us to review was it 2 a power? Was it multiplying? Product of a power property. Yeah, to multiply powers of the same base, add the exponent. That's what it's saying. So if we have a to the m power times a to the n power, we could just add m plus n together. A squared plus a to the third is a to the fifth. That's what we did. We just used x in our example. So it says, okay, with that, can we find the product? So that's a good test for us. Can we do that? Let's see. I got a problem right down here. The fourth root of n times the square root of n. Now, we don't know how to do anything with radicals, but we do know how to do with exponents. And we know how to switch back and forth. So the first thing we would do is switch this. So this is n to the 1/4, right? Because the n is to the first power. There's only one n under there. times, and this is into the, what's the number outside here? If there's no number, that's an automatic assumed to be a 2 because it's the square root. So that's into the 1/4 times into the 1/2. Well, we know by multiplying we can add those together. So that's the same as n to the 1/4 plus 1/2. We know we can add those together. And we know that in adding, if we're going to add a 1/4 plus a 1/2, we have to convert them to the same denominator. And we know a 1/2 and a 1/4 add up to be 3/4. So this is n to the 3/4. So that's what the 4th root of n times the square root of n is n to the 3/4. And if they want, you have to look, this is where you have to be careful too. It'll say either they want the answer as a rational exponent, or they may want it as a radical, which means we need to go back here. The 4th root of n to the 3rd power. So pay attention. Do they want it in exponent or do they want it in radical? Because it'll tell you, give your answer in rational exponent form. Great, that's right there. Or give it in radical form. Great, that's right there. But that's our first exponent property, is multiplying, for that first example they give us. And they go through 4 videos to work that out that I just did on paper. So that here's, and these are like 5-second videos or something, 6 seconds. So it says, yeah, I know I can write radicals as rational exponents. So what to do first is they rewrite those, just like I showed, as n to the 1/4 times n to the 1/2. So the first thing you have to do is convert them to exponents. Then the next thing you do is I can add them. See, I know the product property tells me I can find the product of those two by adding them. Then got to find the common denominator. So 1/2 plus 1/2, 1/4 plus 1/2. You got to make the common denominator and then write it back as a radical. It tells us at the top to give us it in radical form. It just says find the product. So since they gave it to us as a radical, we give them the answer in a radical since they didn't specify. But that's the same thing we got. We just did on paper there, the 4th root of n to the 3rd. All right. This one says express the product of the 5th root of d to the 3rd power times the square root of d in radical form. They tell us how they want the answer. So let's do that one on paper real quick. Let me write this down first. We're using d this time. 5th power times the square root of d. Okay, so I've got that problem down here at the bottom. The 5th root of d to the 3rd power times d squared. So let's rewrite this as exponents. Remember, what's on top stays on top. So what's inside there stays on top. What's on the outside becomes the denominator. So that is d to the 3/5. What's inside stays on top. What's outside goes on the denominator on bottom. Times what's inside is just a 1. What's on the outside? Remember, if it's just the square root, that means that's automatically a 2. We don't have to see a number. We know automatically if there's nothing there, that's a 2. We just make that assumption. So now we have d to the 3/5 times d to the 1/2, which means we know we can add those together. 3/5 plus 1/2. So we got to do that math to have a common denominator when we're adding fractions. So we're going to have to change both of them because 2 does not go into 5. So we can multiply by 1 on both sides. So this time we'll multiply that by this one, 2 divided by 2. We'll use a different one over here, 5 divided by 5. So multiply it by 1 on both sides, which gives us 2 times 3. Remember, multiplying, we just straight across. 2 times 5, 6/10 plus 5 times 1 is 5. 2 times 5 is tenths. So this is 11 tenths. So that means this equals d to the 11 tenths. Now this is a little different case because this is more than 1, right? 11 tenths. 10 tenths is 1. So this is the same thing as d to the 10 tenths times d to the 1/10. And this is just 1. 10 divided by 10 is 1. So this will equal d times the 10th root of d. Almost looks like DVD. No, it's 10th root. This is the 10th root of d, right? D to the 1/10 is the 10th root of d. 10 divided by 10 is 1. So this is d to the first power. So that just stays that side, d. So let's see how they did that. But that's our final solution right there. D times the 10th power of d. Show the answer. Okay, they just, step 1. Here's step 1, 3/5 times 1/2. So we did that. We did 3/5 times 1/2. Step 2, apply the product property. That's what it said, 3/5 plus 1/2. So we were figuring the 3/5 plus 1/2 down here. Rename the fractions to the least common denominator. That's where we made 6/10 plus 5/10. We did right there. Step 4, add them, and they get 11/10, just like we did. And they just left it like that. And that's fine too. That's fine too. We could say, okay, if this is going to be 11/10, that's the same thing as the 10th root of d to the 11. These are the same. I just simplified it a little more. Same. Those are the same. Where are you going, pencil? All right. Take a look at the radical expression 10th root of d to 11. Since the exponent's an improper fraction, we can simplify it in one of two ways. Okay, so here you go. Here's where they're simplifying it. And they simplify it to d times the 10th root of d, like I had already done on there. And they say you can do it, since it's an improper fraction, make it d to the 1 1/10, which means d to the first power times d to the 1/10 power. Their second example is to go ahead and convert it to a radical first. And so they know that's the 10th root of d times d times d times d 11 times, which means it's d times the 10th root of d. Either way, you can simplify it to what I had that looks like DVD, kind of, the 10th root. All right, show more on finding the product of powers with rational exponents. So here's another example. Got the 3 steps if you need another example to go through. Let's see, simplify. Check out simplifying t raised to the 8/5 power. So again, that's more than 1 as well. 8/5 is larger than 5/5. So it ends up t times the 5th root of t to the 3rd power. Because you could pull out that 5/5 as just a t. 5 divided by 5 is t to the 1st power. All right, that was all page 1. Wow. Let's talk about dividing. Use the quotient property with rational exponent. So the quotient property. Quotient of a power. So it says, if we have, go back and add to our notes up here. Quotient.
Yeah, that's the one file that it's like the 28.
So the quotient property means if we have, let's see, what's the example they had on there? I want to use the same numbers. Okay, I'm going to use x though. X to the 5th divided by x to the 3rd. That's called a quotient when you're dividing. In this case, we could take x and subtract 5 minus 3.
So
Take
next
the one on
week,
top
we
first, take the one on bottom as second. So that is the same as x squared. How do we know that? Well, on top is x times x times x times x times x divided by x times x times x. Well, x divided by x is 1. X divided by x is 1. X divided by x is 1. There's nothing left to cancel out those, so that just leaves x times x over 1, which is x squared. And that's how the quotient property works. So we can subtract, which means if we have a fraction, I'm sure they're going to give us an example of that real quick here. Here we go. R to the 6/7 divided by R to the 2/7. I knew they were going to give us an example real quick. R to the 6/7 divided by R to the 2/7. So that means we can take R and subtract the exponents. 6/7 minus 2/7. Now the nice thing is they already have the same denominator, because as we talked about with subtracting, we have to have the same denominator, just like addition. 2 and 4 have to become the same number. C's already have the same number, so this is just equal to R 6 minus 2 4/7. That's the answer to this problem right there. Just subtract the exponents. 6/7 minus 2/7. All right, so they go through the steps here, 3 steps. 6/7 minus 2/7. That means you can subtract the exponents. They already have the same thing. Oh, they want it as a radical at the end, though. They want it as a radical. So we do need to change it. We didn't have it as a radical. We had it as a rational exponent. So a radical, the number on bottom is outside. And it's R to the 4th. All right, so that's as a radical. Same number. If this is a rational exponent, that's a radical. So we can't forget, what do they want it? They want it as a radical. So they've got the R equals 4/7. So then they convert that 4/7 to the 7th root of R to the 4th power. Additional review and finding the common denominator. If you need more practice on those fractions, finding the common denominator, 1/2 and 1/4. So you can list all the multiples: 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, 4 times 1, 4 times 2, 4 times 3. And just look for the first number they have in common. 4 is the first number they both have in common. So that would be the denominator you're going for. So if you need to read through that to review fractions, there you go. All right, here's another example on finding the quotient of this and giving it as a radical. First thing you got to do is you got to convert those to exponents. We don't have any radical rules. We've only got exponent rules and fractions. Right? So convert those to rational expressions. So the 8th root of p to the 5th would be p to the 5/8. The 4th root of p to the 1/4. Step 2. Now you can subtract. You got p to the 5/8 minus 1/4. You need to get those the same denominator if you're subtracting fractions. So p to the 8/8, to the 5/8 minus 2/8, because 1/4 becomes 2/8. And then you can subtract 5 minus 2. So you got 3/8. And finally, the 3/8 converted to be the 8th root of p to the 3rd. So another example for you right there. Page 3.
Where?
Raising a power to a power.
Wow.
Okay, this is more for our notes. Back to the exponent properties. I'm going to have to start a new page because we don't have room for that power down there.
Did you forget those tickets from me and Mrs. Facility?
Power property.
Wow, Alani Oaks.
Okay, so this says if we have x to the third power raised to the fourth power. X to the third power raised to the fourth power. Let's think about what that is. That's saying x to the third power is being multiplied by itself 4 times.
Put it in the chat, ma'am, so that we have it.
So we got x to the third power times x to the third power times x to the third power times x. So 4 times.
Wow.
So that means that's x times 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 x. Well, that's x being multiplied by itself 12 times. So we know that's x to the 12th. So that's what this equals, which means you can take the exponents 3 and multiply it times the outside exponent, 4.
Are you on the meet screen?
So if we have powers, we can multiply those 2 times each other. 3 times 4 to get x to the 12th. So that's our power property. And we know it's right because this is x being multiplied by itself 12 times, which would be, oh, I didn't put the 12. I started talking before I finished it. X to the 12th. So let's see what kind of sample problem they give us for this.
Right, I have gotten
C to the 1/2 raised to the 1/4.
one email.
All right. C to the 1/2 power raised to the 1/4 power. And how do they want the answer? They don't tell us. Okay. Well, we'll just wing it on our own on how to. We'll put it in both ways just so we
We're
know.
also working on that.
So now we know, since we demonstrated it up here, that this is the same as C raised to the power of 1/2 times 1/4,
So, you guys,
which
we're
means
almost
this is C, or multiplying, you go straight across. That's C to the 1/8 power. Because it's just 1 times 1 and 2 times 4 when we multiply. Remember our multiplication, you just go straight across. 2 times 3, 3 times 4. So that one's pretty simple. So C to the 1/8, which is also the 8th root of C to the first power, right? That's because that's a 1, so that's just C.
Okay, so pause for a second.
Let's see what they did.
Why are we practicing? One of you can raise your hand and chime in on this answer. Why
Okay,
are we
step 2.
practicing writing emails again, class?
They multiply those together. 1/2 times 1/4.
Alani,
C
what
to
do
the
you guys-
1/8 power. And then they converted it to a rational,
you
I mean,
guys
a
are
radical,
ready? Accept
just
this
like we
class.
did.
You guys are
The
real bad
8th
at
root
writing
of C.
emails and following directions.
All right. So to raise a power to a power, you multiply the exponents. A to the m raised to the n is a to the m times n.
Our parent-teacher conferences
So a to the 5th to the 3rd. We did 3 to the 4th on our example, but that's it right there. When you raise a power to a power and get a rational exponent, sometimes that's a number that's greater than 1. So let's see this. F to the 4th power being raised to the 4/9 power. I don't think this one has sound, so I may not need to present this differently. Let me see.
Stop them. Do that email.
Now, this doesn't have any sound, so I'm not going to change how I present it. I'm just going to show it like this. All right, it says first rewrite the integer as a fraction in order to multiply with the other fraction. So how is 4 written as a fraction? That's a good question because this is f to the 4th. So f to the 4th would be f to the 4/1 because that's what the number 4 is. Multiply it times 4/9. So now you're going to multiply those fractions. So that's 4 times 4 and 1 times 9. So we've got f to the 16th power, the 9th root of that. So we can look for that and simplify the fact that that's the same as f to the 9th times f to the 7th. And the 9th root of f to the 9th is just f. 9th root of f to the 9 is just f. And then you've got the ninth root of f to the 7th. So it's just simplifying that. This was our answer. It appeared 9, the ninth root of f to the 16. But since 16 is larger than 9, we can actually simplify it further by pulling that f out. By saying that's the same thing as 9, the ninth root of f to the 9th, which is just f. All right. Here's a second method, if you want that. 23 seconds. It says start out the same way, multiply the exponents to get to the 16/9. That worked the same way. And then went ahead, instead of converting it to a radical, they said, well, let's just make an improper number. So f to the 1/7/9, it's the same as f to the first times f to the 7/9. And so that's just a simpler way to quickly summarize that, simplify it by just taking the improper fraction right off the bat. 16/9 is 1 7/9. So that's f to the first and f to the 7/9. F to the first is just f. So you can simplify it either way. Learn more and simplifying a power raised to a rational exponent. So this is another example for you if you need that. Z to the third to the 1/5. You multiply that and you got z to the 3/5, right? Because 3 times 1/5 is 3/5. Another example for you. Lots of examples. Negative rational exponents. Okay, this is worth looking at because that's a little different situation. So let's look at this example here. Look at the pattern it forms as you look at decreasing powers of 4. So 4 to the 4th is the same as 4 times 4 times 4 times 4, which is 256. If we divide that by 4, now we just have 4 to the 3rd. 4 times 4 times 4, which is 64. And if we if we convert that and say, okay, now we're going to divide by 4 again. So 4 squared is just 4 times 4, which is 16. And then we can divide by 4 again. Now it's just 4 to the first, which is 4. And we can divide by 4 again, which means 4 to the 0. 4 divided by 1 is 1. Anything raised to the power of 0 is 1. Well, that's a good thing to have as a reminder in our notes. Let me get my pencil back over here. Anything, here, let me draw a line here. X to the 0 equals 1. X equals any number. X raised to the 0 power is 1. X can be any number. 843 raised to the power of 0 is 1. Negative 19 raised to the power of 0 is 1. Any number. So that's a good reminder for our notes. Anyway, back to what they were doing. Can you see that when the exponent decreases by 1, the value of the power is divided by 4, right? 256 divided by 4 is 64, divided by 4 is 16, divided by 4 is 1, divided by, it's 4, divided by 4 is 1. So can we figure out what happens with negative exponents? Oh, so that's a really good one. So let's expand that a little bit on our own. So 4 to the 4th, 4 to the 3rd, 4 squared, 4 to the first, 4 to the 0 power. What about 4 to the negative 1 power, 4 to the negative 2 power, 4 to the negative 3 power? Okay, so we said this was 4 times 4 times 4 times 4. And we know that 4 times 4 is 16. 16 times 16 is 256. So that one's 64. And 4 squared is 4 times 4, which is 16. 4 to the first is just 4 times nothing. So that just equals 4. 4 to the 0 is 1. So every time we divide by 4. we can continue that pattern as we go down in exponents. Every time divide by 4. So if we keep up that pattern, divide by 4, this is now 1 over 4.
Oh, yeah, you're okay. Okay, you're fine.
And this is 1 over 4 times 4, 1/16, which is also 1 over 4 squared. This be 1 over 4 times 4 times 4, which is 1 over 64, which is also 1 over 4 to the third. Ah, I see a pattern developing there. So since we don't like expressing things in negative exponents,
How come you didn't include it?
1 over 4 to the first. If we have x to the negative third power, we rewrite that as 1 over x to the positive 3 power. See, because that's what it equals. Something to the negative third power is the same as 1 over that same number to the positive 3 power. If we have 2x to the negative 2 power, the 2 stays on top and the x squared moves on bottom to make it a positive exponent. To the x minus 2, x has to move down here. I mean, that's the same thing as 2 times 1 over x squared. 2 times x to the negative 2, 2 times 1 over x squared. So it's this. It works in the opposite too. If we have, let's say we have 2y over 3x to the negative 4th power. And it's like, to simplify, we should never have a negative exponent. So the 2y stays on top because it was already on top. The 3 stays on bottom. And the x, we need to move up and make it x to the 4th power. Either way, it can move up or down. If it's negative, move it up. If it's negative on top, move it down. So these equal the same thing. 2x to the 4th on top means now it's a positive because it was negative on bottom. It was a negative down here, it's a positive on top. It was a negative up here, it's a positive on bottom. Move it whichever way you need to move it to make it positive for your final answer. See, 4 to the negative 1, they went to 1/4, which is 1 over 4. 4 to the negative 2, it's 1 over 4 squared, which is 1/16. 4 to the negative 3 is 1 over 4 to the positive 3, which is 1/64. So a negative sign in the exponent turns its base into its reciprocal. It means it's something flipped upside down. All right, raising a base to a negative rational exponent. So recall that the inverse of a positive is a negative, and the inverse operation of multiplication is division. So 4 to the third means 1, 2, 3 fours multiplied times each other. It's 64. Inversely, a negative exponent tells you to divide the base by that number. That's how we end up with a negative number. 4 to the negative third, instead of multiplying by 4 3 times, means you're supposed to divide by 4 each time. 1 divided by 4, divided by 4, divided by 4. So that's where you get the 1 divided by 4 to the third. So as a fraction, the 1 would be on top. 1 divided by 4 to the third. That's how you get that number. So that's why that works. What if the negative started in the denominator? You would still go the same way. That's what I was talking about. 9 to the negative 1/2 becomes 1 over the square root of 9, because that's, negative square root of 9. The other one, if it's already in the bottom, then you're going to move it to the top to make it positive. So you just took it out from underneath the 1 and made it a positive exponent. All right, and then there's more on how to simplify if you need that. Oh, it's even a video for you. So I'll leave that. You can watch that video if you need it. Here is the lesson summary. Let's see how much they have in there. It has the product property that we should have in our notes now. The product property. When you multiply 2, like d to the 2/5 times d to the 1/2, that means you can get the same denominator and add them. Exponents are added when you multiply two exponents. When you divide, you subtract. When negative, you move from top to bottom or bottom to top. They have a couple of pages of practice problems for you. You try dividing rational exponents. Drag and drop the expressions that show each step in correct order. So if you have x to the 2/3 minus x to the 1/3, that doesn't look like the next step. That looks like maybe an answer. Maybe the last one. Oh, I guess it's the second one because we're going to convert it. Now there's the converted answer at the end, and there's how you get there. Apply the quotient property, subtract and simplify, and then rewrite. So there's a few of those you can practice. There's more practice problems here. Simplify. Do you know how to simplify that? Write it as a rational exponent. So an exponent. So remember, if it's a power to a power, you can multiply those together. 1/3 times 1/4, 1 times 1, 3 times 4 should be x to the 1/12. Multiply exponents. So there's 5 problems there. Multiplying quotients. Here's the last one. Fill in each box to simplify the expression. 7 to the -1/2 would be the same as 1 divided by 7 to the positive square roots, which is 1/49, right? 7 to the -2 power is 1/7 to the +2 power, and 1/7 squared is 49. So there's 5 problems there as well. And then the next page has more practice for you. You try 1, you try 2. Simplify, express the answer using a rational exponent. So if you multiply those together, what do? You add them, right? And then there's a second one. Use what you've learned about negative exponents to solve this. 25 to the -1/2 power would equal which of those answers? So, all right, that is all of our lesson. Let's go to the second assignment for this week. Woo! Look at this. These are not multiple choice. You have 5 problems that are all not multiple choice. I need to see how much this is worth. I'm going to make this worth more than the multiple choice. So if it's not already set to be worth more, I will make it worth more. All right. Is the expression x to the 3rd times x to the 3rd times x to the 3rd the same as x to the 3 times 3 times 3? Why or why not? Explain your reasoning. And remember, if you're going to use some kind of equation in your answer, use the insert equation button. Because if I say, well, x to the 9th would equal, I want it to look like x to the 9th would equal, instead of just x underscore 9 equal. There's a big difference. I want it to look right. So make sure you use the insert equation button. Insert equation button. I'll say it one more time. Insert equation button. All right, say it 3 times. Rewrite this in radical form, the simplest radical form. So that's where, do you know how to go back and forth? That was that first lesson. But this has a negative exponent. So you've got to write it as a positive exponent, simplify it, and then make it in radical form, as simple as possible. Rewrite this in the exponent form. Pay attention. Some of y'all are going to miss some points because you write it in the wrong form. And rewrite this in simplest radical form. And which of these are equivalent? I like this question. A, B, C, and D. At least 2 of those are equal to the same number. At least 2 of those. Maybe 3 of those are equal to the same number. Maybe all 4 are equal to the same number. But you have to simplify those as simple as you can get. After you simplify all 4, say which ones are the same. Because something's the same. It doesn't say, are any of these equivalent? It says, which of these are equivalent? So figure out, is it two of them the same? And if it is, which two? Is it three of them the same? If it is, which three? Or all four the same? So simplify those. Do the math. Show me the math. You get more points when you show the math, because if you're wrong and you don't show any math, then you either get all the points or you don't get any of the points, because I don't know what you did wrong. But if you're wrong and you show the math, I say, well, they were right here. They're right. Oh, they made a small mistake right there. So I'll only take a small amount off, because the reason they got it wrong is they forgot a negative or something, right? Something simple. Showing your work is better because you can get more points if your answer is wrong. Otherwise, it's all or nothing. And especially since it says justify your reasoning. By doing the work, that's justifying your reasoning. So you have to do that to get all the points. Because even with the right answer, you can't get all the points unless you've shown me how you got that answer. Show each step of the process. Can't get all the points unless you show each step of the process. All right.
That's like saying, hey, Connor, we're going to go see a movie. Do you want to come?
Well, that is the second lesson. So yeah, that's it. 2 lessons,
Is there a problem?
2 assignments,
Do you want to come?
and you have 15 minutes left to work on that. All right. If anyone still needs to do, and I know some of you still need to do, the discussion-based assessment from last unit before you forget everything you knew about systems of equation, put something in the chat that, hey, me, and I will give you a chance now. Since our lesson's over, our whole class is over. So anyone that wants to hang around and do a discussion-based assessment, we can do that now. Otherwise, this is an A day, so I'll be in class Wednesday and Friday. So